Okay, you guys have any questions on anything? Anyone has any questions? All right, so we will continue with this section 10.3, and this section was on polar coordinates. And by the way, did I tell you anything about this Friday?
No.
Oh, did you guys want a day off?
Yeah.
I think we. Okay. I think we need a break, right?
Yeah.
Okay. So let's say Friday is off. Okay. Okay. So this is polar coordinates. I'm giving you off just because you wanted it, right? Okay. There is no other reason. Okay. So 10.3. That's polar coordinates, and we are. Let me remind you what polar coordinates is one more time before I start doing problems. So imagine that you have a you have a x-axis, and I am thinking about the yellow one as the x-axis, and the black arrow is the polar axis. Each one of them is a copy of the real number line. You guys know what a real number line is, right? The real number. So both of them are copies of the real number line. So let's say both of them, the origin is. So let's say for both of them, the origin is right here. So this is the point 0. Okay. Let's say I am now given a point P. Let's say the point P is right here, and I want to know what are the polar coordinates of that point. So what I do is I rotate my polar axis until I intersect that point. Okay. So one way to intersect that point by rotating the polar axis is that we can do the following. Yeah. Well, let me change my point. Okay. Okay. So let's say the point is right here. So that's the point P. So what are the polar coordinates? Well, I rotated it, and what angle did I have to rotate through? The angle that I had to rotate through is, let's say, this angle here, right? So let's call that theta. So the coordinates of P would be, one of them would be theta, and the other would be the point P on the polar axis. Remember, the polar axis is a copy of the real number line, right? So the point P on the real number line represents a real number, right? And I'm going to call that R. So what is R? Well, what is another interpretation for R? So what I'm saying, the polar axis is a real number line, so the point P on it is a real number R. What's another interpretation for R? It's the distance from the O, right? From the origin. So I get these are the polar coordinates. However, depending on how you rotate through, how you rotate the polar axis in order to get to the point P, there are many other possibilities, right? So one is, notice that once I have the point theta, right? I mean the angle theta. In fact, if I rotate the polar axis by an angle which is theta plus a multiple of 2 pi, right? So if I add a multiple of 2 pi with theta, right, I am always going to come back to the same area, same place, right? Same quadrant. Is that making sense? With theta, if I add a multiple of 2 pi, I'm going to come back to the same quadrant. The positive side of the polar axis will come back to the same quadrant, right? So if I have the 2 times n pi, so that's a multiple of 2 pi, right? And here n could be any integer, okay? So n could be n could be any integer. So it could be 0, plus or minus 1, plus or minus 2, and so on. So for any integer n, the angle theta plus 2n pi and the angle theta, right, their position would be the same. So I get the same point P. Now, so that means that the way I am rotating then is the following, right? So if I'm adding, say, 2 pi to it, to theta, what's the angle? What's the angle if I add 2 pi? I'm going to be starting it right like this. So so that angle is what? Theta plus 2 pi, right? Everybody's okay? So if I add 4 pi, right, I'm going to come back to the same point. Okay, so yet another way would be that I can notice that if I rotate the polar axis by theta plus pi, what is theta plus pi? Theta plus pi is this angle here, right? So that's theta plus pi. So if I rotate that way, then which side is the positive polar axis? Which side is the positive side? Well, this would be the positive side of the polar axis now, right? The other side would be the negative side. Remember, it's a copy of the real number line. So on one side of 0, it's positive numbers. On another side of 0, it's the negative numbers, right? So if I rotate by theta plus pi, right, what would be the coordinates of P then? What would be the coordinates of P? Negative R, because now it's on the negative side of the polar axis, and this is theta plus pi. So all these coordinates, right, they give you the same point. And not only that, now, because again, if I if I theta plus pi, and then if I add any multiple of 2 pi, right, 2n pi, I am always, the positive side of the polar axis will always be directed by the red arrow, right? Everybody's okay? So I have theta plus pi, and then if I add any multiple of 2 pi, I'm always going to be directed by that arrow, right? Red arrow. So I get all these points are giving me the same point. Now, to make things a little bit easier, I'm just going to take R to be most of the time positive. Okay. Any questions on this? Anyone? Okay, so now let's try to do some problems. Example. Let's say, I mean, one of the examples, did we look at that? Converting points. Okay. So let's say I have, let's do another one. Let's say I have, I want to convert the point, let's say negative 3 comma pi over 6 from polar coordinates, to rectangular coordinates. Okay, so how do I do that? Well, in order to do that, I need to know what? Yeah, I need to know the conversion formulas, right? So remember that this is what we did. From the point P, if I make a vertical line onto the x-axis, then notice, can someone tell, so let's say P has, we are only using the coordinates R and theta, right? Theta could be any of the infinitely many possibilities, right? Theta could be any of the infinitely many possibilities. And let's say we are using R, and R could be negative or positive. So in any case, from that, the right triangle that I have now, can someone tell me what is R? What is R from this triangle? Anyone? Yeah, R is the hypotenuse, so the square of R would be what? Let's say this side is X, right? And this side is Y. So what is X and Y then? X and Y are the rectangular coordinates, right? X and Y would be the rectangular coordinates of P, right? Because it's the, what is Y? Y is the distance from the x-axis, and X is the distance from the y-axis, right? And where would be the location of y-axis? Well, it will be vertical at this point, right? So what is R squared then? X squared plus y squared by Pythagoras theorem. And then can someone tell me what is X? In terms of theta, let's say. X would be R times sine theta, right? Why? Because X divided by R is what? X divided by R is the opposite over the hypotenuse, right? So that's sine theta. So X would be R sine theta. Same way, what is Y? R cosine theta. Everybody's okay. And finally, one more thing that I want to do is, Okay, so one more thing I want to do is, what is tangent of theta then? Tangent of theta is the opposite over adjacent, right? So this is going to be y divided by x. Everybody's okay? So yeah.
I have those written down from last week.
Yeah.
And X and Y are switched.
Oh yeah, because you're right. The way I labeled is I switched my x and y. So let me match what I had before, okay? Just for consistency. Okay, so this would be my, this side would be x, this side would be y. Usually that's what we do, right? Usually we take the first coordinate to be x. So this would be x here and y here. Thank you. So, what's that?
The tangent.
No, I think the tangent is correct.
Oh, okay.
Yeah, I made a mistake when I did the tangent. So, okay. So here's so how do I convert then? Well, I have to compute the rectangular coordinates, right? So what is x? X would be r. What is r in this case? It's negative 3 pi over 6, right? But what is the angle pi over 6? What's that? The angle is 30 degrees, so if you rotate it 30 degrees, the point is where? On the other side of the polar axis, right? On the negative side of the polar axis. So it's negative 3 and cosine of pi over 6. So what is that? I guess what I was asking you, what's the location of this point? Is it in the first quadrant, second quadrant, third quadrant? Third, yes. So we know that in third quadrant both x and y are what? Negative. So what is this? This quantity here, negative 3 multiplied by cosine pi over 6 is what? Cosine 30 degrees, right? What is that? Root 3 over 2. Okay, and then what is y? Negative 3 sine pi over 6, which is negative 3 times half. And you can see what they are. So these are so computing rectangular coordinates from polar is pretty easy. Okay. Now the opposite is usually the difficult one. So convert the point. Last time, what point did I have? Anyone remembers? One. Okay, so let me do today 2 root 3. Or did I do that either? Okay. Did I do negative 2?
Yeah, negative 2.
So I didn't do positive 2. Okay, let's do that. So convert the point from rectangular coordinates to polar coordinates. Okay, so in this case, first of all, the first thing you want to compute when you go from rectangular to polar is you want to compute r. So what is r? Well, we know r squared is what? X squared plus y squared, right? So what is x in this case? What is x in this case? 2. So I get 2 squared. And what is y? 2 root 3, right? That's the second coordinate. And then if I add them, what do I get? Whoa. What do I get if I add them? 4 plus 4 times 3, right? What is that? 16, right? 16. So R would be plus or minus what? 4. Okay, so let's take R to be 4 first, okay? And then we will, okay, R to be 4. And if R is 4, then how do I compute theta? Well, first of all, we know that X is R times what? Cosine theta. We know that Y is R times sine theta. Oops. Okay, so then what is this equation? X is 2, R is 4, cosine theta, and here Y is 2 root 3, 4 sine theta. So what is cosine theta from here? Cosine theta would be half. Here sine theta would be what? Root 3 over 2. So basically what are we looking for? Is it obvious that the point is in the first quadrant? Both X and Y are positive, right? So it's in the first quadrant. So we are looking for an angle in the first quadrant, right? If I take R to be positive, I want my positive side of the polar axis to be in the first quadrant, directing toward the first quadrant, right? So then, what angle can you think of for which these are the values? Yes, so this would be, so we know that one of the values would be that it is pi divided by 3. That's 60 degrees. Okay, but then we can add any multiple of 2 pi to it, right? Any multiple of 2 pi, and we will still be at the same place, right? My polar axis will be still directing in the same direction as theta, and it will be in the first quadrant, right? Everybody's okay? All right, so what if R is negative? What if R is negative? What is R is negative 4? In that case, what would I get for, what are the equations I'm going to get? I'm going to get 2 to be what? Negative 4 cosine theta, right? I'm going to get 2 root 3 to be negative 4 sine theta, right? So in that case, what is cosine theta? Cosine theta would be negative half, and sine theta would be negative root 3 over 2. Now, R is negative, right? So that means my point is still in the first quadrant, right? So my point is in the first quadrant, but now I want my polar axis to be directed away from the point, right? The point I want to be on the negative side of the polar axis. So what angle would that be? Do I have to do any work? What's that? Yeah, you're just going to add, with the theta that you already obtained for the positive R, you're just going to add a pi to it. Am I making sense? Because remember what I did here? When I got the arrow by the red sign, right? What did I do? I just added pi to theta, right? And that gave me the negative R, right? So in this case, the angle that's going to give me this negative R value is the theta that you already obtained, and you're just going to add a pi to it. Always works, okay? And whatever that is, you have to add multiple of 2 pi to that. So this is 4 pi over 3 plus, then you want to add a multiple of 2 pi. And I should probably just write it down here, because if anytime I add a multiple of 2 pi, I come back to the same point. Everybody sees that. So what are my answers? Well, my answers should be written in the form, when I have positive radius, I call it r to be the radius, and then the angle is pi over 3 plus 2n pi. When r is negative 4, the angle is pi over 3, 4 pi over 3 plus 2n pi. Now, can someone tell me, do I even have to do this calculation for negative 4? Do I even need to do the calculations for negative 4? No, whatever you got for positive 4, right? Whatever you got for positive 4, the angle pi over 3, just add pi to it, and then a multiple of 2 pi. That's all the difference is, always. Everybody is okay with that? Whatever you obtain for positive r, just add a pi to it, and that's going to give you the point for negative r, the coordinates for negative r. Am I making sense? So all I'm saying is that this work that I have done here, I really don't need to do that. Okay? So from now on, I won't probably do it. I'll just say that if you take negative r, then this would be the angle. Any questions on that? Everybody's okay with that? Okay. Here is another example. Sometimes if you have a equation in x and y in rectangular coordinates, you might be asked to convert it to polar coordinates. Okay, so let's say you want to convert the equation. Let's say I have x squared plus 2x plus y squared equals to 3 from rectangular coordinates to polar coordinates. I might just say I have a rectangular equation versus a polar equation, okay, to mean that one is using polar coordinates, the other one is using rectangular coordinates. Even though that language is not standard, I just say that rectangular equation versus polar equation, okay. That's not a standard language though. So this is, how do I do this? How do I convert it to a polar equation? Well, just use your conversion formulas, right? So in this case, what do we know about x? Well, first of all, if you shouldn't replace x and y right away. You should look for, if you have x squared plus y squared, you know what is that? R squared. So I can combine these two, right? So I can rewrite the equation as x squared plus y squared plus 2x equals to 3. So then I can say x squared plus y squared is simply r squared, and then I could say, what is x? What is x? X is r cosine theta, so that's equals to 3. Okay, and then you can leave it there. Yeah, you just leave it there. So this is what you get. Everybody's okay? Okay, so the opposite way is that so convert the polar equation. Let's say the polar equation is R is 2 times sine theta. 2 times sine theta. Two rectangular equation. 2a rectangular equation. So what is that? I have R is equal to 2 sine theta. Now usually what you're going to do is you're just going to replace R by the root of x squared plus y squared. But in this case, a trick will do us a better job, which is multiply both sides by R. You get R squared is 2R sine theta. And then you can now say easily R squared is x squared plus y squared. And then what is R times sine theta? That's 2i. Okay. Now you're done here if the question is just to convert, right? Convert into a rectangular equation. However, let's say you're asked to recognize what curve is represented by that equation. Okay. So if I look at this equation, what do I have? I have x squared plus y squared minus 2i equals to 0. And I want to complete the square for y. So what I'm going to do is I am going to add, what should I add to complete the square on y? If I add 1 to both sides, right, I'm allowed to do that. And y squared minus 2y plus 1 factors into what? Y minus 1 squared. And so what I have then is x minus 0 squared plus y minus 1 squared equals to 1 squared. And that's the equation of what? So we know that this is the standard equation of a circle. And what's the center? Center is 0, 1, and the radius is 1. Everybody's okay? So I can sometimes, when you convert from polar to rectangular equation, you can recognize what that curve is. Yeah?
Will you feel get close to that?
Yes. Finally, somebody spoke up. I was actually checking if somebody says something. I didn't forget about it. No, I did forget about it. So you can blame Nathan. You can blame Nathan. So he's maybe I should give him a different problem.
Yes, yes, too.
So here's the quiz problem. I have handed out the paper, blank paper, so you should get a copy of that. So here's the question, okay? Okay, so that's the only problem on the quiz. What you have to find is the arc length, right?